Welcome all. Today we are going to discuss about restricted Boltzmann network and its advantages and restricted Boltzmann machine and their layers, etc. So now we can go to the presentation and look at what is this restricted Boltzmann network. Now let's see what is restricted Boltzmann network. A restricted Boltzmann network is a type of artificial neural network used in machine learning and unsupervised learning tasks, particularly in domain of deep learning and feature learning. So, this restricted Boltzmann network are a unique class of neural networks that enables unsupervised learning and is very popular during the early 20s and is very effective in solving complex problems like image recognition, collaborative filtering, etc. Okay, now let's see what is a Boltzmann machine. The Boltzmann machine is a type of stochastic recurrent neural network that can learn and retrieve complicated information. That this machine is used to retrieve complicated information, and this RBM, so that means um, a restricted Boltzmann machine is having two layers. One is an visible layer and the other one is the hidden layer. Each layer is composed of neurons and these neurons are not connected with each other. Also, why are they important? They enable unsupervised learning, meaning they can learn patterns without any labels, which means that this machine can learn patterns from the big data sets and that's patterns from big data sets without labels. This makes them useful in many different fields, including image processing and recommendation system. So this Boltzmann machine is useful in image processing and recommendation system. There is also some limitations to this Boltzmann machine due to their computational complexity. It's challenging to train Boltzmann machine on large scale data. So on large scale data there are some restrictions or limitations to this Boltzmann machine. Now we can see how are RBMs different from traditional neural networks. There are three key features, that is first one architecture. RBMs have two layers as I have said earlier. They have two layers, that is visible layer and hidden layer. The next the next difference from the traditional neural network is the learning process. The RBMs uses a unsupervised learning process, whereas traditional neural networks are supervised in learning. Also data types. RBMs are used for unsupervised learning of large data sets. That is, these RBMs are working on a large data sets, whereas traditional neural networks are used for classification of labeled data. Here we can use unlabeled data. In traditional neural network we are using the which type of data? The labeled data are used there. Okay. So, what are the applications of RBMs in machine learning? So, there are mainly three applications. First one is the face recognition. RBMs can learn the different features of a face and identify individual faces. Using these RBMs, we can identify which person is this, or the features of a specific person. Also, recommendation systems. RBMs can learn a user's preference by analyzing past behavior and recommend new products based on those preferences. These RBMs learn from the past experience and can produce recommendation system. Also, drug discovery. RBMs can help identify new drug targets and evaluate their safety and quality and cost efficiency. Okay, there are some advantages and also disadvantages to RBMs. First, we can look at what are the advantages of these RBMs. That are first one unsupervised learning, second one fast learning, and third one good data representation. First one unsupervised learning. RBMs can learn from unlabeled data without the need of manual tagging. Without the use of manual tagging, these RBMs can learn from unlabeled data, while in the traditional network we are using the labeled data. Then second one, the fast learning. RBMs require less computational power than the other neural network, making them more efficient. These RBMs need a less computational power, which we are comparing to the other neural networks. The third one is good data representation. RBMs can effectively identify essential features in data that can facilitate decision making. So these RBMs also are good in decision making. Also, there are some disadvantages or limitations or challenges. We can move on to that. So limitations and challenges of RBMs. Limitations. First one, complex structure. RBMs are become complex and computationally expensive, especially when dealing with large datasets or training deep architecture. While training deep architecture or dealing with large datasets, these RBMs become complex in structure. Second one, may not always converge to a solution. In some cases, RBMs may struggle to converge to a satisfactory solution, especially when the data is high dimensional or when the learning rate is not well tuned. The third one is sensitive to the selection of hyperparameters. The performance of the RBMs is highly dependent on the selection of hyperparameters. Now, what are the examples of these hyperparameters? The hyperparameters are such as learning rate, batch size, number of hidden units, and number of Gibbs sampling steps in congestive divergence. These are some limitations of these RBMs. And also there are some challenges. First one, gradient based techniques become difficult with large data sets. With the use of large data sets, as we can see that as we know that the big data or machine learning is working with a large data sets, so the gradient based techniques become difficult while using this large data sets. Difficulty in parameter optimization is the second challenge, and in third, more complex than traditional neural network. As we said earlier that this RBMs is little complex than the traditional neural network. As a conclusion, we can say that we are concluding it in two ways. That is, current state of RBMs. RBMs have significantly contributed to the process of machine and deep learning and challenged traditional deep learning algorithm. So this RBMs is very useful in machine learning and deep learning. In the future of RBMs lies in hybrid models, where RBMs are combined with other deep learning architectures such as autoencoders and variational autoencoders to create more versatile models. That's all about this RBMS, that is restricted Boltzmann machine. Hope you all understand this. Thank you.